There was a time when we believed planets came in just a few familiar types. Small rocky worlds like Earth, gas giants like Jupiter, ice giants like Neptune. It seemed simple. Then astronomers started discovering planets around other stars. Hundreds became thousands. Thousands became more than 5,000 confirmed worlds. And something unexpected happened. Many of those planets didn't fit into any category we knew. Some were hotter than lava. Some were darker than coal. Some rained molten metal. Others completed an entire year in less than a single Earth day. The universe turned out to be far more creative than we ever imagined. But every once in a while, a planet appears that makes scientists stop and ask a different question. Not what is it, but how can a planet like this even exist? That question led astronomers to a distant world nearly 73 light-years from Earth, a planet known as TOI-270d. It may be covered by an ocean, unlike anything in our solar system. Its atmosphere could stretch thousands of kilometers into space. Its water may never freeze, never boil, and never behave the way water does on Earth. Some scientists believe it could be the first true Hycean world ever discovered. Others think it may be something else entirely. The truth is, we still don't know. And that's exactly what makes TOI-270d one of the most fascinating planets ever found. Today, we're traveling beyond the solar system to explore a world that could completely change the way we think about planets, oceans, and even life itself. For most of human history, every planet we knew belonged to our own solar system. Mercury, Venus, Earth, Mars, the 4 giant planets farther out. That was our entire sample of planetary diversity. It was like trying to understand every animal on Earth after seeing only 8 of them. Everything changed in the 1990s, when astronomers confirmed the first planet orbiting a sun-like star beyond our solar system. Since then, discoveries have accelerated at an incredible pace. Powerful space telescopes, sensitive detectors, and decades of observations have revealed a universe filled with planets of every size and every orbit imaginable. One of those discoveries arrived in 2019. NASA's Transiting Exoplanet Survey satellite, better known as TESS, detected a small, repeating dip in the brightness of a nearby red dwarf star. The star is called TOI-270. Every time one of its planets crossed in front of the star, it blocked a tiny fraction of the starlight. The change was incredibly small, but it happened with perfect consistency. Those tiny dips revealed something remarkable. Not one planet, not 2, but an entire planetary system. 3 worlds orbiting the same small red star. The 2 inner planets immediately looked familiar. They were relatively small and completed their orbits in just a few days. Interesting, but not unusual. The 3rd planet, however, quickly became the center of attention. TOI-270d. At first glance, its numbers didn't seem extraordinary. It's about twice the size of Earth. Its mass is several times greater than our planet's. It circles its star once every 11 days. Simple enough. Except, those numbers place it inside one of the strangest regions in planetary science. Astronomers call it the radius gap. For years, researchers noticed something unusual while studying thousands of exoplanets. Planets roughly the size of Earth were common. Larger planets similar to Neptune were also common. But between those 2 groups, there was a surprising shortage. It's as if nature preferred making small rocky planets, or much larger gas-rich planets, while creating very few in between. TOI-270d sits almost exactly in that mysterious transition zone. That immediately raised a difficult question. Is it a giant rocky planet? A small Neptune? A water world? Or an entirely different class of planet we've barely begun to understand? The solar system offers no comparison. There isn't a single planet here with the same combination of size, mass, and density. For the first time, astronomers found themselves studying a world with no familiar reference point. That alone made TOI-270d an exciting discovery. But the deeper scientists looked, the stranger it became. One clue came from its density. Density tells astronomers far more than size alone. 2 planets can have the same diameter, yet be completely different inside. A planet made mostly of iron would be incredibly dense. A planet surrounded by a thick atmosphere would be much lighter. TOI-270d landed somewhere in the middle, too light to be entirely rocky, too dense to resemble Neptune. Its interior became one of astronomy's biggest question marks. Researchers began building computer models. Some suggested a deep global ocean covering the entire planet. Others proposed a thick hydrogen-rich atmosphere sitting above an enormous layer of superheated water. Another possibility imagined a rocky interior buried beneath thousands of kilometers of high-pressure ice and liquid water. Each model explained part of the data. None explained everything. And that's one of the most exciting parts of modern astronomy. Discovering a planet is only the beginning. Understanding it can take decades. Unlike Mars or Jupiter, astronomers can't simply send a spacecraft to TOI-270d, at least not anytime soon. Everything we know comes from light. The tiny changes in brightness as the planet passes in front of its star. The subtle wobble of the star caused by the planet's gravity. The faint fingerprints left behind when starlight passes through the planet's atmosphere. Those measurements may seem almost impossible. Yet together, they'd allowed scientists to estimate the size, mass, orbit, and even hint of the atmosphere surrounding a world trillions of kilometers away. It's one of humanity's greatest scientific achievements. We're learning about places we'll probably never visit, using nothing more than light that has traveled across space for decades. And in the case of TOI-270d, that light is telling us a story unlike any planet we've studied before. Because if current models are even close to correct, this isn't just another exoplanet. It may represent an entirely new kind of world. A world where oceans don't resemble Earth's. Where the atmosphere may be thicker than anything humans have ever experienced. And where the boundary between ocean, planet, and sky may not exist at all. When most people hear the phrase ocean planet, they picture another Earth, blue water, clouds drifting across the sky, waves crashing against distant shores. TOI-270d is almost certainly nothing like that. If this planet is truly covered by water, its oceans would be unlike anything found anywhere in our solar system. The first difference is their scale. Earth's oceans are surprisingly shallow when compared to the size of the planet. Even the Mariana Trench, the deepest place on Earth, reaches only about 11 kilometers below sea level, relative to Earth's radius. That's little more than a thin layer of moisture on the surface. TOI-270d could be very different. Some interior models suggest its oceans may extend hundreds or even thousands of kilometers beneath the atmosphere before reaching anything solid. If those models are correct, there would be no coastlines, no islands, no continents, no beaches, just a planet-sized ocean stretching far beyond anything our minds are used to imagining. That alone changes almost everything we know about planetary environments. On Earth, continents shape the climate. They redirect ocean currents. They influence wind patterns. They recycle carbon through plate tectonics. Without continents, an entire planet would operate under a completely different set of rules. Scientists are still trying to understand exactly what those rules would be. Another major mystery lies beneath the surface. As depth increases, pressure rises. On Earth, the pressure at the bottom of the Mariana Trench is already more than 1,000 times greater than the pressure at sea level. Now extend that ocean not by another few kilometers, but by hundreds. Eventually, water begins behaving in ways we've never experienced on Earth. At extremely high pressures, ordinary liquid water can transform into exotic forms of ice. This isn't ice because it's cold. It's ice because the pressure forces water molecules into new crystal structures. Scientists call these materials high-pressure ice phases. Some are known as Ice 6, others as Ice 7 or Ice X. Despite the name, these forms of ice may exist at temperatures hot enough to melt steel. They're not frozen landscapes. They're entirely new states of matter created by immense pressure. If TOI-270d contains layers like these, its ocean may not rest directly on a rocky surface. Instead, a thick shell of high-pressure ice could separate the liquid ocean from the planet's interior. That raises an important question. If water never touches rock? Can the chemistry needed for life still develop? It's one of the biggest unanswered questions in planetary science. The atmosphere may be just as unusual. Recent observations with the James Webb Space Telescope suggest TOI-270d is surrounded by a dense atmosphere rich in hydrogen. That's a major difference from Earth. Our atmosphere is dominated by nitrogen and oxygen. Hydrogen is only a trace component. On TOI-270d, hydrogen may be one of the main ingredients. A hydrogen-rich atmosphere changes everything. It traps heat differently. It affects atmospheric pressure. It influences cloud formation. And it alters the chemistry taking place above the ocean. Some researchers believe this combination of a deep ocean and a hydrogen atmosphere represents an entirely new category of planet. They call these worlds Hycean planets. The name combines two words, hydrogen and ocean. It's a relatively new idea, first proposed only a few years ago. If confirmed, Hycean planets could be among the most common potentially habitable worlds in our galaxy. That possibility has attracted enormous attention, not because scientists know Hycean planets support life, but because they may dramatically expand the number of places where life could exist. Temperature adds another layer to the mystery. TOI-270d orbits much closer to its star than Earth does to the Sun. One complete year lasts only about 11 Earth days. Normally, that would suggest an extremely hot planet. But the situation isn't so straightforward. Its host star is a red dwarf. Red dwarfs are much cooler and much smaller than the Sun. Even though the planet orbits very close, the star itself produces far less energy. As a result, estimates place TOI-270d in a temperature range that is intriguing rather than impossible. The atmosphere may still be extremely hot by Earth standards. Some models suggest surface temperatures of several hundred degrees Celsius. Others predict cooler regions depending on cloud cover, atmospheric circulation, and heat distribution. The exact conditions remain uncertain. And that's an important reminder. Astronomy often deals in probabilities, not certainties. Every new observation helps narrow the possibilities, but nature doesn't always reveal its secrets all at once. Another challenge comes from the planet's rotation. Because TOI-270d orbits so close to its star, many astronomers suspect it may be tidally locked. That means one side of the planet permanently faces the star. The opposite side remains in constant darkness. If that's true, there would be no sunrise, no sunset. One hemisphere would experience endless daylight. The other would never see the star at all. For years, scientists assumed that tidal locking would make planets uninhabitable. The day side would become unbearably hot. The night side would freeze. But modern climate simulations tell a more complicated story. A sufficiently thick atmosphere can transport heat around the planet. Powerful winds may carry energy from the illuminated hemisphere to the dark side, reducing the temperature difference between the two. Some climate models even predict a broad transition region between day and night. Astronomers call it the Terminator Zone. Instead of permanent day or permanent night, this narrow band would exist in a state of eternal twilight on some exoplanets. It may even provide the most stable conditions anywhere on the planet. Perhaps the most remarkable part of TOI-270d isn't what we know. It's how much we still don't know. Scientists continue debating whether this world is truly an ocean planet. Some believe it resembles a scaled-down Neptune with an unusually dense atmosphere. Others argue that the evidence points toward a deep global ocean hidden beneath hydrogen-rich clouds. Both interpretations explain much of the available data. Neither explains everything. That uncertainty isn't a weakness. It's exactly how science moves forward. Every observation rules out one possibility and strengthens another. Every new telescope reveals details that were invisible just a few years earlier. And TOI-270d has become one of the most valuable targets in that search. Because somewhere beneath those clouds, beneath that atmosphere, and beneath an ocean that may be deeper than anything we can truly comprehend, lies the answer to a much larger question. Not simply what TOI-270d is, but how many different kinds of planets the universe is capable of creating. As astronomers continue studying its atmosphere, another possibility has begun attracting even more attention. What if this planet is more than an exotic ocean world? What if its atmosphere contains the chemical fingerprints of life? That question has turned TOI-270d into one of the most closely watched exoplanets in modern astronomy, and it's where our journey leads next. For decades, the search for life beyond Earth followed a simple idea: find another planet like ours. A rocky surface, liquid water, a familiar atmosphere, orbiting within the habitable zone of a sun-like star. It seemed like the most logical place to begin. After all, Earth is the only example of life we have. But every new generation of telescopes has forced astronomers to rethink that assumption. The universe rarely follows the rules we expect. Sometimes, it creates worlds that are completely unlike Earth. And yet, those worlds may still deserve a closer look. TOI-270d is one of them. Unlike planets inside our own solar system, astronomers can't send a rover to TOI-270d. There are no close-up photographs, no samples, no orbiters mapping its surface. Everything scientists know comes from a technique called transmission spectroscopy. Whenever TOI-270d passes in front of its star, a tiny fraction of the starlight travels through the planet's atmosphere before reaching Earth. That atmosphere absorbs specific wavelengths of light. Different molecules leave different fingerprints. By studying those fingerprints, astronomers can begin identifying the gases surrounding a planet located trillions of kilometers away. It's one of the most remarkable achievements in modern astronomy. We're not seeing the planet directly. We're decoding information hidden inside light. That task became much easier with the launch of the James Webb Space Telescope. Unlike previous observatories, Webb was designed to study infrared light with extraordinary precision. Infrared wavelengths reveal molecules that are often invisible in ordinary visible light. For exoplanets, this is revolutionary. Instead of simply measuring a planet's size or orbit, scientists can now investigate its atmosphere in unprecedented detail. TOI-270d quickly became one of Webb's most important targets. Not because astronomers expected to find aliens, but because the planet occupies one of the least understood categories ever discovered. Every observation helps answer a much larger question. How do planets between Earth and Neptune actually evolve? The first results surprised researchers. Evidence pointed toward an atmosphere rich in hydrogen. Scientists also detected carbon dioxide. That discovery alone revealed important clues about the planet's chemistry. Carbon dioxide doesn't prove life, but it helps researchers understand how the atmosphere formed and how it changes over time. Some studies also suggest the possible presence of water vapor. Others indicate methane may exist under certain conditions. Each molecule becomes another piece of an enormous puzzle. None of them answers a mystery by itself. Together, they begin revealing the character of an entirely different world. One thing is becoming increasingly clear. TOI-270d probably isn't a simple ocean planet, nor is it an ordinary mini Neptune. Instead, it appears to occupy a fascinating middle ground. Some researchers describe it as a Hycean world, a planet with a hydrogen-rich atmosphere covering a vast global ocean. Others argue the atmosphere may be so deep and hot that liquid water can exist only under extreme pressure. Both possibilities remain scientifically plausible. The evidence continues to evolve. That's one reason astronomers are so careful with their conclusions. Science isn't about announcing the most exciting answer. It's about discovering the most accurate one. Whenever a new exoplanet makes headlines, one question always follows. Could there be life? It's an understandable question, but scientists approach it differently. Before asking whether life exists, they first ask whether the environment allows the necessary chemistry. Does the planet contain carbon, water, energy, stable conditions over long periods of time? Only after those questions begin receiving positive answers does the conversation move toward biology. TOI-270d is still in that first stage. Researchers are investigating chemistry, not civilizations. And that's exactly how good science should work. Curiosity comes first. Conclusions come later. There's another reason TOI-270d matters. It represents a population of planets our solar system simply doesn't have. For centuries, our understanding of planets was shaped by 8 familiar examples. Then exoplanets revealed something extraordinary. The most common planets in our galaxy may be worlds that don't exist around our own sun. Many Neptunes, super-Earths, Hycean candidates. These aren't rare exceptions. They may actually outnumber planets like Earth. That realization has completely changed planetary science. We're no longer asking how other worlds resemble our own. We're learning how diverse planets can become when nature is allowed to experiment. The coming years may answer some of the biggest questions surrounding TOI-270d. Future observations with the James Webb Space Telescope will continue refining measurements of its atmosphere. Even more powerful observatories are already being planned. Projects such as the Extremely Large Telescope in Chile will study exoplanets with unprecedented sensitivity. Future space missions may detect additional molecules, improve estimates of temperature and atmospheric pressure, or even reveal entirely unexpected chemistry. Every new observation narrows the possibilities, and sometimes it opens completely new ones. That's the nature of discovery. The closer we look, the more the universe surprises us. TOI-270d may never become humanity's destination. At a distance of roughly 73 light-years, even our fastest spacecraft will require tens of thousands of years to reach it using today's technology. For now, the journey is made by light alone. Photons leaving that distant star travel across interstellar space for more than 7 decades before finally reaching Earth's telescopes. Only then can scientists begin decoding the story they've been carrying all that time. It's a remarkable thought. The information arriving today actually began its journey while the middle of the 20th century was still unfolding on Earth. Astronomy doesn't simply let us observe distant places. It allows us to look into the past. Perhaps that's the greatest lesson TOI-270d has to offer. For generations, we believe we understood what a planet should look like. Rocky worlds, gas giants, ice giants. The discovery of exoplanets shattered that simple picture. Now we know the universe builds planets in ways our own solar system never imagined. Some may be covered entirely by oceans. Some may hide beneath enormous hydrogen atmospheres. Others may combine properties we've only recently begun to recognize. TOI-270d reminds us that Earth isn't a blueprint for every world. It's only one possibility among countless others. And somewhere among those countless worlds, another planet may already be waiting to challenge everything we think we know. Every new planet we discover changes our map of the universe. But every once in a while, one changes the questions we ask. TOI-270d isn't important because we've solved its mystery. It's important because we haven't. Somewhere beneath its distant clouds, hidden behind an atmosphere we've only just begun to understand, is a world unlike any we've ever known. And perhaps that's the greatest discovery of all. The universe is far more imaginative than we are. We're simply learning, one planet at a time.